Hi! So for today, we're going to continue our discussion all about the rules of differentiation. So let's start again with the derivative, this time with the derivative of a reciprocal. So it is given by the formula dy over dx is equals to the derivative with respect to x of 1 over v, of which v is our function, that is equal to actually the negative of d derivative with respect to x of that v divided by v squared. Okay? So for us to understand this concept, we need to have an example. So for our first example, let's say we have a function that is in terms of reciprocal, 1 over x plus 1. In this case, x plus 1 will be our v. So we shall be using again this formula in order to get the derivative of this function. So the dy over dx, or the derivative of y with respect to x, is equal to the negative d over dx of our v. In this case, our v is the denominator, which is x plus 1 divided by v squared. So we will simply square the denominator. Okay? In order to simplify that, we need to get the derivative of this. So the derivative of x is actually 1, and the derivative of 1 is 0, since that is constant, and that is divided by x plus 1 squared. And for our answer, we can say that the derivative of y with respect to x of this function is actually equal to negative 1 over x plus 1 squared. And that is our answer. Okay? So another example is this. Y is equals to 1 over 3t squared minus or plus 4t minus 5. So this is again an example of a function that is in terms of reciprocal. So in this case, our v is equal to 3t squared plus 4t minus 5. So applying the formula, we have dy over dx of this y is actually equal to the negative d over dx of v of the new denominator, which is 3t squared plus 4t minus 5 divided by v squared. So that is 3t squared plus 4t minus 5 squared. So we need to get this, the derivative of this. So we can actually evaluate the derivative of this. This is a power times a function. So the derivative of that will be 3 times 2 is it times t, plus the derivative of 4t is simply 4, and the derivative of negative 5 is simply 0. So we have now this 3t squared plus 4t minus 5 squared. So simplifying, our answer should be, this is negative, and we have here 3 times 2 times t, that is 6t plus 4 divided by 3t squared plus 4t minus 5 squared. That shall be our answer. Okay? So for our next rule is actually the derivative of a function with rational exponents. So many students are kind of scared with radicals or functions with rational exponents. So in order for us to get the derivative of a function with rational exponent, we have the dy, we have the formula dy over dx is equals to d over dx of x raised to 1 over m, okay? And that is equal to, simply by power formula, 1 over m times x raised to 1 over m minus 1, and that shall be our formula. Where m, take note, where, oops, I'm sorry, where, let me just rewrite that. Where m should not equal to 0. Okay? This shall be our formula. So for our example, we have here y is equals to square root of x plus the cube root of x. So find the derivative of this function using this formula for function with rational exponents. So we all know that upon simplifying this formula, y is simply equal to x raised to 1 half plus x raised to 1/3. So as you can see from our previous discussion, that this is in terms of power. So we can use power rule or this formula to again get the derivative of this. So we have y prime of the derivative of y with respect to x. Simply copy, bring down the exponent times x raised to 1 half minus 1, okay? And simply plus 1/3 x raised to 1/3 minus 1. Okay? So, upon simplifying that, we'll be having 1 half times x, 1 half minus 1 is negative 1 half plus 1/3. 1/3 minus 1 is actually negative 2/3. So, negative 2/3. So, we have that. So, in order for us to eliminate the negative exponent, we shall bring down or get the reciprocal of this x, both this negative 1 half, x raised to negative 1 half, and this x raised to negative 2/3. So we have 1 over 2 x raised to 1 half plus 1 over 3 times x raised to negative 2/3. Or, I mean, that is already a positive. So that, let me just erase that part. Okay, so it should be 2/3. So upon simplifying, we know that x raised to 1 half is simply 1 half square root of x plus 1/3. This is in 2/3, x raised to 2/3. So that is x squared or the cube root of x squared. Okay, so this shall be our answer. So another example is if you have y that is equal to square root of x plus the cube root of let's say x cube root of x squared. Okay, so again we shall express this y in terms of its exponent. We have x raised to 1 half plus x raised to 2/3. So we wish to get the derivative of that. We shall be applying the formula a while ago. Okay, this formula, or simply, in other words, this is a power formula. So we have 1 half base times x raised to 1 half minus 1 plus 2/3 times x raised to 2/3 minus 1. Okay, so the derivative, upon simplifying 1/2, x raised to 1/2 minus 1 is x raised to negative 1/2 plus 2/3, and x raised to 2/3 minus 1, so that is negative 3 plus 2, that is negative 1/3. Okay, so if we simplify this, we shall bring down or eliminate this negative exponent by getting the reciprocal of x. So we have now 1 over 2. Since that is raised to 1/2 already, we can say that it is square root of x plus 2 divided by 3. So 1/3, that is already the cube root of x. Cube root because we have the denominator here, which is 3, and that corresponds to our cube. And because we get the reciprocal of this, the negative here is eliminated. It becomes a positive 1, so that the exponent 1 is inside this x. So that we have our answer for the derivative of this example. Okay, so let's go now to what we call the chain rule. Okay, the chain rule. So the chain rule has the formula. This is another type of differentiation rule, wherein it is much, I would say, complicated than any of the rules. So let's try. This is the formula. dy over dx is actually equal to dy over du times the du over dx. So as you can see here, from the formula of chain rule, we have dy over du times du over dx. So if you multiply these two, simply the du will cancel and we get the dy over dx. So how does that work? So for example, we have a function that is actually equal to this, 4x squared minus 2x plus 5 raised to 3. So we have to identify here in this function what is the u, and we shall get the derivative of that u with respect to x. And of course, our y is actually this function. Okay, so to find u, always look for the inside. Okay, as you can see, we have a function 4x squared minus 2x plus 5 raised to cube. So the inside, or the 4x squared minus 2x plus 5 term, is, we shall call that u. So if we substitute that with u, we will be having y is equals to u cube. Okay, if u, let me just rewrite, is 4x squared minus 2x plus 5, then our y is equals only to u cube. Okay, so did you get that? So if we wish to find the dy over dx, because we have to find the dy over du, okay, this is right here, and we have to find the du over dx. So in order to find dy over du, we need to find that dy over du. So derivative of y with respect to u. So this is only a power formula. We have 3u 3 minus 1, or simply 3u squared. So we already have the dy over du. How about du over dx? So du over dx is actually what? So we have here, let's say, let me just have a space here. So du over dx is simply, if we have this u, we're going to get a derivative of that, du over dx. So in order to get the derivative, this is a power rule times a function or a constant. So we have 4 times 2 times x raised to 2 minus 1 minus the derivative of 2x is simply 2, and the derivative of 5 is simply constant, which is 0. Oops, I'm so sorry, 0. So simplifying, we have 8x minus 2. Okay, if we shall be using this formula to get the dy over dx, okay, dy over dx is actually dy over du, of which this is our dy over du. We have 3u squared times the du over dx, which is this, 8x minus 2. So, back substituting the u is equals to this. So, we have now the 3 times 4x squared minus 2x plus 5. That is our u. It is raised to squared multiplied by the function 8, or the term 8x minus 2. So, our answer for dy over dx, so we can leave it here. This should be our answer for finding the derivative using chain rule of this example. Okay, so okay, so for number 2 example, we have, again, let's say we have a function y is equals to square root of, let's say, t squared minus 2t plus 3, and it is actually raised to 3. Okay, so in order for us to apply the chain rule, again, our formula for the chain rule, let me just write here, dy, dy over dx is actually du, or over dy, I'm sorry, dy over du times du over dx. So what are we going to do here is, again, set this inner part of the function as u, okay, not including the q. So if we set that, u is equals to t squared minus 2t plus 3, then therefore y is equals to, simply, this is raised to 3 and it is inside the square root, so definitely this is u raised to 3 halves. Okay, 3 halves because this u is raised to the third power and it is actually evaluated in square root. So we have u raised to 3 halves. Oops, I'm so sorry. Oops. Let me just rewrite again. So this is u raised to 3 halves. So we can get the derivative of y with respect to u because we need that according to our formula. So this is simply power formula, 3 halves times u raised to 3 halves minus 1. Okay, and that is equal to 3 halves u, 3 halves minus 1, that is 2 times negative 1, negative 2 plus 3, that is 1 half, if I'm not mistaken. Okay, 3 halves minus 1, that is 1 half. Okay, so we have here 3 halves u raised to 1 half. Okay, we finally found the dy over du. But how about du over dx? So our u is this. So we shall derive that. So since our parameter here is in terms of t, so du over dx will be simply replaced by du over dt. Okay? So it so happened that if we find the derivative, it is always with respect to x, but in this time, we need to get the dy over dt. Okay? So the derivative of y with respect to t. Okay? See, still, same rule applies. So we have here the derivative of u with respect to dt. Okay? So we have the derivative of u, t squared, that is 2t minus 2t. The derivative of 2t is simply 2, and the derivative of this 3 is simply 0. So we have the du over dt 2t minus 2. So the dy over dt is equal to dy over du times the du over dt. So this shall be our chain rule formula. So notice that we only replaced dx with dt because we are actually getting the derivative of this y with respect to t. So to get the dy over dt, you have dy over du, and that is 3 halves times u raised to 1 half. So 3 halves times u raised to 1 half times 2t minus 2. Okay, so we have here, to simplify, 3 halves of u raised to 1 half. What is our u? The u is equal to this. So we have t squared minus 2t plus 3 raised to 1 half, or square root, multiplied by 2t minus 2. So as you can see here, we can further simplify this. So we have 3 halves t squared minus 2t plus 3 raised to 1 half. And we can factor out 2. We have 2 times t minus 1. So since this is a multiplication, we can simplify that. We can cancel it out. So we have the answer 3 times t minus 1 times t squared minus 2t plus 3 raised to 1 half, or 3 is equal to 3 times t minus 1, the square root of t squared minus 2t plus 3. So this shall be our final answer in determining the derivative of our example with respect to t. Okay, so that's all for now. So thank you so much for listening, and I hope you guys enjoyed this video. If you find this video helpful, don't forget to click like and subscribe. Thank you, and God bless you.